Hey everyone, welcome back, and today let's solve Leetcode problem 2914 titled Minimum Number of Changes to Make Binary String Beautiful, the daily Leetcode challenge problem for today. So we're given a zero-indexed binary string S having an even length. Note that it is a binary string, meaning only ones and zeros. And a string is beautiful if it's possible to partition it into one or more substrings such that each substring has an even length, basically moddable by 2, having a remainder of 0, and each substring contains only ones or only zeros. And we may change any character in S to 0 or 1. Also something very important to note here. So we need to return the minimum number of changes required to make the string S beautiful. So at first, looking at this word minimum and partition, you may think, okay, this is probably a dynamic programming problem, right? It seems pretty advanced. But the reality is you don't need recursion, dynamic programming, or any of these advanced algorithms to solve this problem. It really just takes a pretty simple kind of use case of logic, and it's pretty straightforward. Okay. So in example 1, we have the input string S to be 1001, and we'd output 2. Why is that? We can change S at index 1 to a 1, and then S at index 3 to a 0. Then we get a resulting string of 1100. 1 has a length of 2 and only ones. 0 is a window that has a length of only 2, and which is even, and it only has zeros. And so that is going to be the minimum number of changes we need to make that string beautiful. It's 2, right? In example 2, we have the input string S to be 10, and we'd output 1. Why? Because we can't just partition 1 and 0 by itself as two separate windows. Although they are only ones and zeros, they don't have an even length. 1 is not even. And so we can change S of 1 to 1 to get that string 1, 1, right? And 1, 1 is beautiful. Why? Because it has an even length. 2 is moddable by itself, which is 2, and we only have ones, and that is the minimum number of changes we really need to make that string beautiful. An alternative method would be to change this 1 to a 0. Then we'd have 0, 0. That still is beautiful because it only has zeros rather than only having ones, and it also has a length that's even, right? It's moddable by 2. And finally, in example 3, we have the input string S to be 0, 0, 0, 0. All of these characters are already equal, and so we don't need to make any changes, right? It's already beautiful. Our input is already beautiful, and we'd output 0, right? We don't have any changes to make. It's just going to be a 0 number of changes, right? So with that out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so the first thing I'm going to do is actually just have a quick changes variable, right? It's simply going to be a counter variable, right, which is going to ultimately store the total number of pairs that actually differ from each other. And we'll simply use a for loop like we usually do for most problems to iterate or go through all the strings in incrementations of 2. Why? Because each iteration of this loop is going to check a pair of characters if we loop by 2, or rather increment by 2 each iteration. And inside this loop, we'll check by comparing each pair of characters, and if they differ, we want to increment the changes counter, right? The number of pairs that actually differ, right? So to better explain, now let's go ahead and start coding this up. So what I'm going to do first is actually simply have a changes kind of line here. Like I said before, changes equals to 0, right? We're just initializing it to 0 because we haven't actually traversed through the array yet, right? And it's simply going to keep track, again, of the number of character pairs in our string that are different or differ from each other. And every single time we find a pair of characters that differ, we can increment our change by 1, and at the end of the loop, it's going to contain our final answer of what is the minimum number of changes we need to make that string beautiful as we go through pair by pair. Now let's actually iterate over our input string S. So I'm going to say for I in the range, and since we're incrementing by 2 each time, I'm going to start from the 0th index for the initial value. I'm going to go up to the length of the S inclusive up until the last index. And this is some Pythonic stuff here. I want to have a third parameter, which is optional in this case, along with my second parameter technically as well in my for loop, and I'm simply going to increment by 2 each time. Typically the default value is 1, and so we don't really need to have to even pass it as a parameter. In this case, since I'm not actually using that default value of 1, I'm incrementing by 2 each time to get that pair stimulation. I'm going to pass in a third parameter of 2, right? So once we do that, now that we've actually checked every single pair of characters, again, where I is the index rather than the element, now we need to say if S at this index I in this current iteration, or rather iteration of this string, if it's not equal to the ith plus 1th element. In that case, we need to increment our changes by 1. So changes plus equals 1. Why? Why do we have to do this? What does this really mean? Okay, so if the two characters in our current pair in this iteration are actually different, if they don't match, where s at I is the first character in this pair and s at I plus 1 is the next consecutive or adjacent character in this pair, then we actually have to say, or rather, again, we're using this ternary operator to check if they're actually different or not, right? And if these are different, then if that's true, we have to actually increment our changes by 1. Why? Because we've encountered one more difference. And by the end of the loop, again, change is going to tell us the number of differing pairs, the number of pairs that aren't equal, that differ from each other, right? Where s at I is not equal to s at I plus 1. And sorry, this is not a ternary operator. This is simply a regular not equal to operator. Sorry if I said ternary. But now at the end of this code, we simply have to return, well, the number of changes we have outside of this for loop once we're done iterating over our input string s. And as you can see, if I were to submit this right now, this would actually be accepted. Pretty simple solution. And it is just about as efficient as you can get. Okay, so let's just kind of step back and understand what this code does overall. I might have talked a little bit too fast. Let's sort of slow down for this part. Okay. So what do we do first? First, we have to increment, or rather initiate our changes. It's going to be 0. It's going to have your final answer. That's why we're returning changes. But what do we do after that? What is these main 3 lines of code really saying here? Okay, so we're simply iterating over our string in steps or incrementations of 2, where we look at each consecutive pair of characters. And every single time we find a pair of characters that are different, they differ from each other, they're not equal, we have to increment our changes counter by 1, right? And once that loop has checked all of the different pairs in this string, it's going to hold or store the number of differing pairs, and we can return this as the solution, right? So for the time complexity, this is going to be big O of n, or linear time, where n is going to be the length of the string. Why? Because we're really only iterating over this string once. It is a one-pass solution, and so this is going to be a big O of n runtime complexity. And memory complexity-wise, this is going to be constant, because we only really use a fixed amount of extra space. The change is integer variable. We don't really use any auxiliary space or any data structures to actually calculate anything or compute or store any elements from our inputs, and so this is going to be a constant time memory space solution, regardless of the size of our input string s. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.